Welcome to Pre-Technical Mathematics. This video lecture is on vectors and trig functions. Chapter 8, Section 1. Okay, first thing is we want to establish the difference between scalars and vectors. We're going to be working mostly with vectors. Scalars are quantities that have size or magnitude but no direction. Maybe time, volume, that has no direction, right? Speed, distance, things like that. Now vectors are a quantity that has magnitude and direction. So it is demonstrated graphically as a vector. It has a quantity and a direction. Let's see. Let me show you resultant vectors. We refer to, when we're adding vectors, here's a vector A. And here's a vector B. Now we connect the two vectors from start point to end point, and that is known as our resultant vector. We'll also take a look at the component method. We'll have one vector here, and we'll have one vector here. And if we draw a little parallelogram, see this is parallel to this, and this is parallel to this. We have our resultant vector. So we're going to be working with this. First we'll work graphically, and then we'll add numbers to it. Okay, here the vectors are given. Relative size and the direction. We have A, B, C, and D. Now what we want to do is add some of the vectors together. Remember that you are adding them tip to tail. So we'll start out with B. That'll be like this. We'll add C. Like that. And then we'll add D. Like that. Our resultant connects the beginning, oops, missed a little bit, to the end. So this is our resultant. Okay. This was B, this was C, and this was D. Let's try one more. C minus D. So we'll put C up here. We've got C. And now we want a minus D. When you have a minus, you go exactly opposite of the vector that you're shown. So that would go this way, wouldn't it? Minus D. And our resultant would be right there. I think I've got one more for you. Yes. I wanted to show you what you do when you have multiple vectors. So we have C, there's our C, and we have two D's. So you just connect them, tip to tail. There's one, there's another, and this would be the resultant. I've got one more, a little more complicated. We need 4C. Let's start out down here near the bottom. That's 1, 2, 3, and 4. Minus 3B. Now, that would go in the opposite direction of this. So 1, 2, 3. Minus 2D. That's not going to be pretty. But what we do is we go minus D, minus D. And our resultant is right here. So we sidetracked a little bit and then overrode it. Okay. Here's one for you. Try it and then check your answers in the course information. Right, now we want to talk a little bit about component vectors. We started to talk about this in the beginning. Let's look at it a little bit more. This is the origin, and we refer to the x value as px. That's just a label that we give it. And we refer to this value as py. Our resultant will be in the middle, and that is p. So if we put this into a triangle, let's see how we would superimpose that. This would be P. This would be PX. And I could transpose a little bit off there, PY over to here. Now I've got a little triangle that we should be able to work with trig functions. Okay, so what does px equal? Px equals p, the hypotenuse, times the cosine of theta. Here is theta. Py equals p, the resultant, times the sine of theta. Okay, so let's keep that in mind, and we're going to be working with that. Alright, here's our first components. we have a magnitude of 16 and an angle of 212. Well, let's see where that is. My lines just don't go straight. Okay, this is 180, so 212 would be in here somewhere. There it is. This is 212. And we said the magnitude is 16. So we said to find our x and y values, here is the y, and this is the x. To find the px value, we take 16 times the cosine of 212 and we should get negative 13.569. Okay, so our x came out negative. That's because it goes in this direction. It's negative. What about our py? What can we tell from our diagram here? It's also going to be negative, isn't it? Py is 16 times the sine of 212 degrees. And that should give us negative 8.479. Okay, so we've just found the x and the y component of a given vector. Here's the same thing, except this time we call it p, and theta equals 317. Well, let's find out where that is. This is 270, this is 360, so it should be in here somewhere. So that angle is 317 degrees, and P is 24.6. What did we say our components would equal? Px is P 24.6 times the cosine of 317. And that should equal 17.991. Notice that the x is positive. That's this distance right here. But we can see again that our py is going to be negative. So before I even get started, I know I better come up with a negative number. And we're going to take that by the sine of 317 degrees. And after we plug that in, we should end up with negative 16. That didn't come out very well. 777. All right. Here's one for you to try. Now, don't let this radians scare you. I should have given you an example with the radians. All you need to do is change your mode on your calculator to radians. Alright? And then you'll you'll come up with the correct answer. So we can express theta, the angle, in radians or degrees. This is the end of this video lecture.